Imagine a city, not of grand palaces or sprawling empires, but of grinding poverty, where the very waste of daily life, the muddy runoff and discarded refuse, became the unlikely fuel for a global transformation. This is Birmingham in 1750, a seemingly unremarkable industrial town on the cusp of an unprecedented boom, powered by an astonishingly humble source. How did dirty water, a symbol of squalor and neglect, evolve into the very lifeblood of the new industrial world, churning the gears of progress and reshaping human civilization? This is a story of ingenuity, necessity, and the raw, unpolished power of a city determined to forge its own future. In the mid-18th century, Birmingham was a burgeoning settlement, a lively hub of artisans and merchants, but far from the industrial powerhouse it would become. Its landscape, though dotted with small workshops, still bore the hallmarks of a largely agrarian and craft-based society. Fields stretched beyond the town's growing perimeter, and small streams meandered through the land, their waters often murky from daily human activity. Sanitation was a constant struggle. The concept of clean, flowing water for industry was a luxury, not a given. Power sources were limited to the whims of nature, muscle, wind, or the slow, rhythmic turn of a traditional water wheel, often dependent on the fickle flow of a cleaner river. Yet, even amidst these challenges, a nascent entrepreneurial spirit flickered, driven by a growing population and an insatiable demand for goods. The mills of this era weren't the colossal factories we envision today, but rather modest workshops where skilled hands toiled, often aided by the simplest forms of mechanical assistance. The unsung hero waiting in the wings was water power, not in its pristine, majestic form, but in its most accessible, often neglected state. The fundamental principle was simple. Moving water possessed energy that could be harnessed. Unlike the unreliable wind or the limited capacity of animal power, water, even when muddy or sluggish, offered a continuous, if sometimes inconsistent, source of energy. Early steam engines, while revolutionary, were still in their infancy, expensive to build and inefficient to run, making them impractical for widespread application. Water power, however, was democratic. It required less capital, simpler technology, and could be adapted to the smallest of streams. The advantage for early industry was clear. It offered a pathway to mechanization that was both affordable and readily available, even if it meant contending with the less-than-ideal conditions of Birmingham's local waterways. The challenge was not just to use this power, but to innovate, to refine, and to make it work despite its dirty origins. Birmingham was about to prove that resourcefulness could overcome seemingly insurmountable obstacles. This wasn't an overnight revolution, a sudden flash of brilliance. Instead, it was a gradual, organic growth, born out of sheer necessity and the relentless pursuit of efficiency. The local conditions, a terrain crisscrossed by numerous small watercourses, coupled with a fiercely independent and inventive population, created a fertile ground for change. The city's inhabitants weren't waiting for a grand river. They were looking at every ditch, every brook, every puddle, and asking, how can this power our ambition? Birmingham was about to prove that innovation could spring from the most unlikely places, powered by the most overlooked resources, transforming a landscape of squalor into an engine of global change. Before we continue, subscribe to the channel and tell us in the comments where you are watching from. The problem of power was a constant dilemma for Birmingham. Unlike mighty industrial centers situated on broad, navigable rivers, Birmingham was landlocked, crisscrossed instead by a network of smaller streams, brooks, and natural springs. These waterways, often modest in flow and frequently burdened with the refuse of an expanding town, seemed an unlikely foundation for an industrial revolution. Yet, it was precisely these seemingly insignificant veins of water that became crucial for the city's unprecedented development. Ingenuity blossomed from scarcity. Local entrepreneurs and engineers, rather than lamenting the absence of a major river, began to systematically harness every available drop. This meant constructing intricate systems of mill ponds, artificial reservoirs designed to store water during periods of low flow or overnight, and carefully positioned weirs to raise water levels, creating the necessary head for driving water wheels. These were not grand civil engineering projects on a national scale, but rather localized, pragmatic solutions, often built with local materials and immense community effort. They transformed what might have been viewed as natural obstacles into essential infrastructure, demonstrating a remarkable adaptability. Initially, the application of this water power was relatively straightforward, extending and enhancing existing trades. The earliest mills were often dedicated to grinding corn, ensuring a steady supply of flour for the growing population. Others were fulling mills, where mechanized hammers pounded woolen cloth, densifying the fibers to create sturdy fabrics, a process once painstakingly done by hand or foot. For Birmingham's burgeoning metal trades, water power was a godsend, operating massive bellows that dramatically increased the heat of forges, allowing for larger-scale smelting and more efficient working of metals. This was a critical transition point. The shift from traditional crafts, where human or animal muscle dictated output, to early industrial processes driven by the relentless, tireless force of water. Specific examples, though often lost to history's finer details, point to numerous small workshops dotted along the Rhea and Cole rivers, each a hive of activity, contributing to Birmingham's growing reputation as a manufacturing hub. These diverse productions, from basic foodstuffs to essential industrial components, showcased the sheer versatility of water-powered machinery even in its nascent stages. Innovation under pressure became Birmingham's defining characteristic. The challenge wasn't just finding water, but making dirty water work. Silt, debris, and inconsistent flow were constant adversaries. Engineers and millwrights developed ingenious solutions. Settlement ponds to allow sediment to fall out, screens and filters to prevent larger debris from damaging machinery, and sophisticated reservoir management techniques to ensure a continuous power supply, even during dry spells. This constant adaptation to environmental constraints fostered a culture of practical engineering. Figures like Matthew Boulton and James Watt, while famously associated with the steam engine, were deeply immersed in understanding the dynamics of power generation and site selection. Boulton, with his Soho manufactory, meticulously chose a location with ample water supply for initial operations, even as Watt worked on improving steam power. Their insights into efficient energy utilization were shaped by the very real constraints of harnessing natural forces, clean or otherwise. They understood that the most effective power source was the one that could be reliably and economically integrated into the production process. Yet, this burgeoning industrial growth came with a significant human cost and benefit. The proliferation of mills and workshops drew an ever-increasing influx of workers from the surrounding countryside, transforming Birmingham into a magnet for labor. This led to the rapid growth of factory towns, often unplanned and overcrowded, laying the groundwork for the nascent labor conditions that would define the Industrial Revolution. While these new industries offered employment and the promise of a better life for many, they also introduced new hardships: long hours, dangerous working environments, and the stark realities of urban poverty. Simultaneously, the intensified use of water and the unregulated discharge of industrial waste led to significant environmental consequences. The very waterways that powered Birmingham's ascent became increasingly polluted, a foreshadowing of the ecological challenges that would accompany industrialization globally. Nevertheless, the burgeoning industries connected directly to the daily lives of people, not just in Birmingham, but across the nation. Cheaper goods, from nails to buttons, became more accessible, and the sheer volume of production began to reshape consumption patterns. Birmingham was rapidly becoming a microcosm of the new industrial world, a place where progress and pollution, prosperity and poverty inextricably intertwined. By the late 18th century, Birmingham had truly transformed. What began as a scattered collection of water-powered mills had evolved into a sophisticated industrial ecosystem, making the city a global hub for manufacturing. From the humble production of buttons and buckles to the cutting-edge development of steam engines, Birmingham's output was astonishingly diverse and prolific. The early water-powered mills, seemingly primitive by later standards, were not merely stepping stones. They were the essential groundwork, the fertile soil from which the later adoption of steam power could flourish. The skills honed in designing intricate water management systems, in fabricating robust machinery, and in managing a growing industrial workforce were all directly transferable. The millwrights, who understood the force of a river current, were the same innovators who could grasp the potential of a steam piston. This continuous evolution created an industrial landscape where innovation was a way of life, not an exception. The infrastructure and expertise developed around harnessing water, even dirty water, provided a seamless transition to the age of steam. Matthew Boulton and James Watt, whose names became synonymous with the steam engine, were deeply embedded in this environment. Their understanding of power dynamics and efficient production had been forged in the very crucible of Birmingham's earlier, water-driven industries. The city's ability to adapt, to integrate new technologies into an existing framework of manufacturing, became its defining characteristic, propelling it to the forefront of the Industrial Revolution. Birmingham wasn't just producing goods, it was producing the very means of production for the world. Even today, the unseen infrastructure of this bygone era whispers its story. The intricate network of canals and waterways, initially vital arteries for transporting raw materials and finished goods, and often serving as power channels for smaller mills, remain a visible and functional legacy. These watery paths, once bustling with barges laden with coal and metal, now offer picturesque routes through the modern city, their banks still echoing with the ingenuity of their creators. Historical records and archaeological findings consistently illustrate the sheer extent of Birmingham's water-powered past. Excavations have unearthed the remains of mill races, sluice gates, and foundations of long-gone workshops, each piece a testament to the pervasive nature of this early industrial force. The precision required to build these systems, to manage water flow across varying terrains, and to integrate them with nascent mechanical processes, laid foundational principles for modern engineering. The careful planning of water storage and release, the design of efficient power transfer mechanisms, these were not just solutions for their time, but blueprints for future industrial expansion. Reflecting on Birmingham's story, the core theme resonates powerfully. Necessity, coupled with human ingenuity, possesses an astonishing capacity to transform seemingly adverse conditions into monumental opportunities. The city's humble beginnings, its reliance on often polluted water sources, did not stifle its ambition. Instead, it sharpened its inventive spirit. It forced engineers and entrepreneurs to think differently, to extract maximum value from limited resources. Birmingham's narrative is a microcosm of the broader industrial revolution, demonstrating how modern industry could spring from the most unpromising, even dirty, beginnings. It underscores the profound impact of this era on global development, setting in motion a continuous cycle of innovation and adaptation that continues to shape our world. This remarkable journey encourages us to look beyond the obvious sources of power and progress. It prompts us to consider the often overlooked forces, the seemingly insignificant elements that quietly shape our world. For too long, history has focused on the grand pronouncements and major inventions, sometimes forgetting the gritty, ground-level problem-solving that truly drives change. The story of Birmingham and its dirty water is a potent reminder that solutions often emerge from the very challenges we face. It leaves us with a compelling thought. How many of today's dirty water problems, whether environmental, social, or technological, might in fact hold the seeds of tomorrow's most transformative solutions? The spirit of Birmingham, turning constraint into catalyst, remains an enduring testament to human resilience and innovation.